Hello, General Biology, and welcome to Section 2.2 of Chapter 2. And this section deals with the properties of water. Water's going to be very essential for some of the processes that we're going to learn later on in the chapter. And there's a lot about water that enables life to survive. This is what we're going to talk about. Now that we understand an atom and how it bonds and everything, we can now take a look at that property of bonding in water and see what makes it so special. So take a look at the Earth. How much of the Earth is actually covered in water? You're probably saying about 75%, 70%, somewhere around there, and you're right. And about only 10% of that is fresh water. The other 60% of that is salt water, and salt water we cannot drink. And only of the 10% that's fresh water, only about 1% of that fresh water is available for us to drink. So we have to be very careful with our water. We need to make sure that we don't pollute it, so that it cuts back on what we have available to us. But because you see that the Earth is filled so much with water, that kind of tells you how important water is to sustain life. So it's very significant in its properties to be able to allow organisms like us to live and other organisms to live. You could survive a week to 2 weeks without food. You could only survive 1 to 2 days without water. So it is an essential compound that we need. So in this section, one of the key components that we're going to learn about, or key concepts, is about what makes water so vital for living things. So water is one of the few compounds found in a liquid state over most of the Earth, as we said. And when we take a look at the chemical structure of water, it's neutral. It has, when we break it down, hydrogen, remember we have 2 of them, has 1 valence electron each, and oxygen, when we look at oxygen, has 6 valence electrons each. So when it chemically bonds together, it's often been referred to as the Mickey Mouse molecule. And here's my poor rendition of Mickey Mouse. The hydrogens are going to be here, and the oxygen is going to be here. This is a hydrogen electron. Now we're only doing valence electrons. This is a hydrogen electron. And then the other 6 valence electrons are going to be, whoops, I forgot one, are going to be right there. So we've satisfied our octet rule that we have. So that's what the water molecule looks like. And when we count up all of the charges on it, including the electrons that are on the inside, inner energy levels, sorry about that. There's a total of 10 protons that balance out the negative charges of 10 electrons, so it's electrically neutral. We'll watch this video in class as one of the activities that we do. Okay, so let's take a closer look at that water molecule, and we're going to look at this one that I did not draw. Alright, so we're looking at this water molecule, and remember, hydrogen only has 1 electron total. So that's 1 valence electron that is going to be orbiting around. So each one of these is just going to have that 1 valence electron. And oxygen is going to have 6. So remember that 2 of the 6 actually, they pair with the electrons in the hydrogen. And then we've got 1, 2, and then 1, 2. Okay, take a look at how these electrons are arranged. Where are there more electrons? there's more electrons on the oxygen side of this water molecule than there is on the hydrogen side of this water molecule. So what happens is it makes the oxygen side slightly negative in its charge, and it makes the hydrogen side slightly positive in its charge. And what that does is it allows this water molecule to be able to attract other molecules that have opposite charges. So if I have something with a positive charge, it's going to be able to attract to this negative side. And if I have something with a negative charge, it's going to be able to attach to this positive side. And because of that, because of having a slightly negative and a slightly positive side, this water molecule is called a polar molecule. It has polarity, because it can attract other compounds to it. So think about other water molecules. We've got other water molecules that have a slightly positive side and a slightly negative side, and that means that other water molecules that have a slightly positive side are going to be able to attach, and they're going to be able to hold together. And that's why when you spill water, you get these little water droplets, and it pulls together because of this slight negative and positive attraction, because of this polarity. So you're going to notice that when I wrote the charges on this water molecule, I put the negative, let's erase that. I put the negative charge, or not, in parentheses, and I put the positive charge in parentheses. And that's the way that we write them. Remember when we were talking about ions, and sodium lost an electron and chlorine gained an electron? When we put them next to the actual symbol of the element, we don't have to put them in parentheses. We just put a little plus and a little minus. But when we're referring to this molecule, like we are this polar molecule, then we're showing which side is slightly negative and which side is slightly positive with it. Now, I mentioned to you that because of having the slightly positive side and slightly negative side, that it can attract other water molecules. So the hydrogen side, which is going to be slightly positive, will be attracted to the negative side. And the bonding that happens between that, we call that hydrogen bonding. So water molecules form this hydrogen bonding. And it's a weak bond, but it's strong enough to hold the water molecules together. And I don't know if you've ever seen insects that can walk on water. It's the reason why insects can actually walk on water. Okay, so water is able to form multiple hydrogen bonds, and that's one of the special properties that it has. And when we talk about some different processes that happen because of this, this is another thing that's going to be essential to living things. And let's see what I mean by that. So one of the things that happens is something called cohesion. And cohesion is the attraction between molecules of the same substance. So we've got water molecules that are attracting to each other, and this is cohesion. And as I said, those cohesive forces are what enables insects to be able to walk on top of water, like spiders. Have you ever heard of something called the Jesus Christ lizard? The basilisk lizard. They're common in Costa Rica. In class we're going to watch a YouTube video on this basilisk lizard that just enables it to walk across the water. Wait till you see how cool that is. This basilisk lizard can actually walk across the water. Well, it kind of runs across the water, and it doesn't sink. And that's because of the cohesion that produces the surface tension on the water, and why you can see insects and spiders that can walk on the surface of a pond or a stream in a slow-moving area. Another force is called adhesion, and adhesion is the attraction between molecules of different substances. So let's say you have a glass of water, all right, or a soda, and you put a straw into that water. Okay, so here's our straw. And what's going to happen, that's a pretty poor picture, but there's our straw. And what's going to happen is that water is going to adhere and rise up in that straw just a little bit. And that's adhesion because the water is one type of molecule and it's adhering to the plastic straw, which is another type of material. And that's what causes the meniscus on a graduated cylinder. So here we have a graduated cylinder, and we've got our lines that measure here. All right, and when we fill this up, the water will look like it's just taking a dip down like this, and when you read it, you're going to read it at this level, but you can see on the sides that it's adhering to the sides of that graduated cylinder. And that's adhesion because it's adhering to the water molecule is one type of molecule and the glass is another type, and it's adhering to that. Now this is significant because when we take a look, here's some straws, when we take a look and we put the straws in the water, you can see how the water adheres and it kind of rises it above that level. Well, this is how roots take up water from plants, and it's referred to as capillary action. It's one of the forces that's actually going to draw the water out of the roots and into the plants and up to the stems. So when you think about the column inside, cohesion's holding that column together so that it can move, but adhesion is holding it to the sides of the root so that it can go up and into the plant. Now think of the leaves. The leaves are out in the sun, and they're kind of like somebody sucking on that straw that's going to help pull that water up through the plant and to the stems and to the leaves. So adhesion is important for capillary action that happens in plants. And I should say, if you have any questions that you're not sure about, please feel free after you listen to this, kind of highlight them in your notes and ask me in class if you have any questions. All right, the next thing that we want to talk about is heat capacity. Because water forms multiple hydrogen bonds that hold it together, it takes a large amount of energy that would cause those molecules to move faster, to break those bonds apart. So you have experience with this. You've been swimming in the ocean probably almost all summer if you're down the shore. And you probably noticed that in the beginning of the summer, the water was really on the cool side. July, oh my gosh, I was down in Ocean City, Maryland in July, and we had a day that was, the heat index on the beach must have been like 110 degrees, and the water was ice cold. The next day, same temperature outside, and that water was comfortable. It was nice and warm. I wouldn't say it was ice cold. It wasn't really hot, but it was much more comfortable to be in. So it takes a lot to change the temperature in that water because of the hydrogen bonds. And this is great because we don't want the ocean to suddenly start boiling just because of a hot summer day. And that would kill all the other organisms. So it creates small changes that enables the organisms to be able to live in that water without any drastic changes in temperature. So at the cellular level, water is going to absorb the heat that's produced by cell processes, and it helps to regulate the temperature of the cell so that it is within a livable temperature range. The next thing that we're going to talk about is solutions and suspensions, but we're running out of time in this screencast, so we'll talk about them in the next. See you in a